So hey guys, welcome back to my YouTube channel Hasta Education. So in this video I am going to discuss about the geometrical isomerism, what is the condition and what are the examples. Okay, so let's get started. So first of all, let's see the definition of geometrical isomers. Alright, so it says that the stereoisomers which cannot interconvert at room temperature due to restricted rotation. Okay, so geometrical isomer is nothing but the stereoisomers. Alright, stereoisomers which cannot interconvert at room temperature. Okay, so this is the very important part. The stereoisomers which cannot interconvert at room temperature due to the restricted rotation. Alright, so this is the definition of geometrical isomers. Okay, so let's say here it is a compound. Okay, so this is the sigma bond. Alright, and the rotation is possible around this. Alright, free rotation is possible around this sigma bond. That means this group can come here and this group can come here and this group can go here. Okay, so after the free rotation we can get this compound. Okay, so x goes to here and y goes to here and z goes to here. Okay, we get this compound after the free rotation. Okay, so we can say that free rotation is possible in this case. Okay, so this compound cannot show geometrical isomerism. Okay, so here it is a double bond. Okay, so double bond means it's sigma bond and pi bond, but in this case free rotation is not possible. Okay, there is rotation is not possible, so we cannot get this compound from this. Okay, so this group cannot come to here or this group cannot go to here. Okay, the free rotation is restricted here. Okay, so here in this case free rotation is not possible. That means this system is known as restricted rotatory system. Okay, so the restricted rotatory system shows geometrical isomerism. Okay, so wherever there is restricted rotatory system, that system shows geometrical isomerism. Okay, similarly here it is a cycloalkene, so we cannot interconvert these two group. Okay, this is interconversion is not possible at room temperature, so we cannot get this compound from this. Okay, so here is also the free rotation is not possible, so this is a restricted rotation rotatory system, so it will show geometrical isomerism. Okay, so basically the condition for geometrical isomerism is the compound should contain a restricted rotatory system. Okay, this is the very important thing. The compound should contain restricted rotatory system. Okay, so let's see what are the restricted rotatory systems. So here it is the example of some of the restricted rotatory systems. Okay, in order to show a compound the geometrical isomerism, the compound should contain restricted rotatory system. Okay, option A, compound having this double bond, that means alkene. Okay, this kind of compound can show geometrical isomerism. Then oxime means it can be aldoxime or ketoxime, that means structure of this kind can show geometrical isomerism. Then it comes the imine. Okay, this one is the structure of imine. Then azo compound, then cycloalkene, okay, this one is cycloalkene, this is cycloalkene. Then cumulene or cumulated polyene. Okay, cumulated polyene means a compound of this kind of. Okay, here the double bonds are, okay, this kind of compound are known as cumulene. That means here the double bonds are one after one. Okay, and the last one is spiro compounds or spirans. Okay, spirans means the compound of this format. Okay, this kind of compounds are known as here spiran. Okay, this kind of compound are known as spirans. Okay, so these are the system which contain restricted rotation. Okay, so let's see the condition for geometrical isomerism. The compound containing restricted rotatory system. Okay, the compound containing restricted rotatory system can show geometrical isomerism. Okay, so let's see the condition of geometrical isomerism in alkene. Okay, so here is the structure of alkene. This is a sp2 hybridized carbon, and this one is also sp2 hybridized carbon atom. Okay, this carbon atom is attached with two groups X and Y, and this carbon is attached with two groups A and B. Okay, so here is the condition, and the condition says that each sp2 carbon individually must have different atoms or groups attached to it. Okay, and the terminal groups must be present on the same plane. Okay, so the condition says that each carbon should contain individually contain different atoms or group. Okay, so this carbon should be attached to two different groups. Similarly, this carbon also should be attached to two different groups. Okay, that means X should not be equal to Y and A should not be equal to B. Okay, then in that case this alkene will show geometrical isomerism. Okay, this group should be different from this one and this group should be different from this one. Okay, that's it, the condition of geometrical isomerism in alkene. Okay, here is the condition for geometrical isomerism in oxime. Okay, the structure of oxime is something like this, and this one is a sp2 hybridized carbon atom, and these are two groups attached to this carbon atom, and the condition says that these two groups should be different. Okay, X should not be equal to Y. Okay, so this is the condition for geometrical isomerism in oxime. Okay, these two groups should be different. Okay, next let's see the condition of geometrical isomerism in imine. So this is a typical structure of imine. So again these two groups should be different. Okay, X should not be equal to Y. In that case this imine will show geometrical isomerism. Okay, so here is the geometrical isomerism in azo compound, and we have to note that all azo compounds show geometrical isomerism, right? So let's see the condition for geometrical isomerism in cycloalkene. Okay, and the condition says that ring should contain at least two sp3 atom. Okay, sp3 hybridized atom. Okay, the ring should contain at least two sp3 hybridized atom, and each atom should individually be connected to different groups or different atoms. Okay, so let's say it is a cycloalkene, and this one is your one sp3 carbon atom, and this one is your another sp3 carbon atom. Okay, the condition says that this ring should contain at least two sp3 hybridized atom, and these two sp3 hybridized carbon should individually contain different groups. Okay, so let's say this one is your sp3 carbon atom, and this one is another sp3 sp3 hybridized carbon. Okay, so individual carbon should be connected to different group. That means X should not be equal to Y and M should not be equal to N. Okay, this is the condition for geometrical isomerism in cycloalkene. Okay, the ring should contain at least two sp3 hybridized atom, and both carbon atoms should be individually connected to different groups. Okay, so this is the condition for optical isomerism. Next, geometrical isomerism in cycloalkene. Okay, So cycloalkene containing 3 to 7 carbon shows no geometrical isomerism. Okay, and from 8 to 11 it shows geometrical isomerism. 12 to onwards it also shows geometrical isomerism, but from the cycloalkene containing 8 to 11 carbon atom shows geometrical isomerism, and in this case the cis form is more stable than trans form, and in case of 12 carbon and onwards trans form is more stable than cis form. Okay, so here it is the condition for geometrical isomerism in cumulin. Okay, or cumulated polyene. Okay, so the condition says that number of pi bond, okay, number of pi bond in the cumulated polyene should be odd. Okay, odd number of pi bonds should be present, and atoms or groups at each terminal sp3 carbon should be different. Okay, these are the conditions. Okay, so let's say I have a cumulin like this, x and y, let's say a and b. Okay, this cumulated polyene, that means the cumulin should contain odd number of pi bond. Okay, so 1 2 3, so this contains odd number of pi bond, and the two terminal groups, okay, this group, this carbon and this carbon should be connected to different groups. Okay, that means a should not be equal to b and x should not be equal to y. Okay, these are the two conditions. Okay, number of pi bond should be odd, and each terminal carbon, okay, each terminal sp2 hybridized carbon should be connected to different group. This carbon should be connected to different group, and this carbon should be connected to different group. Okay, this is the condition for geometrical isomerism in cumulin. Okay, so let's see the condition in spiral compounds. So in case of spiral compounds, number of rings should be odd. Okay, this is a spiral compound. Here it is the x y. The condition is similar as the cumulin. Okay, the number of rings should be odd. Okay, this compound should contain odd number of rings, and atoms or groups at each terminal sp2 hybridized carbon should be different. Okay, so these are the terminal sp2 hybridized carbon atom. Okay, so they should be connected to two different group. Okay, so m should not be equal to n and x should not be equal to y. Okay, number of rings should be odd, and each this carbon should be connected to different group. Okay, so these are the conditions for geometrical isomerism in different compounds. Okay, so that's it for this video. Thank you for watching this video. All right.